Can you please all confirm me on the chat window if you're able to hear me? Okay, thank you, Shraddha. Thank you, Devali. Anybody else? Tapas, Venkat, Mr. Yan. Okay, thank you very much. So we'll start about understanding the big data processing using Spark with a language called Scala. So I believe you must have, all of you must have understood the concept of MapReduce before coming to this class. A small introduction about myself. My name is Sandeep Agarwal and I'm a trainer for Big Data, Hadoop and Spark and other languages available in the domain of Big Data. And I've been doing online training for the last couple of years, plus total IT experience I've got more than 20 years. So the today's objectives would be understanding the big data and how do we handle the data which is very huge in volume and high in velocity and has a lot of sources of variety in data types. And then we use the Spark technology or the framework to process the data, which is basically in-memory processing framework, unlike MapReduce, which stores a lot of intermediate data on the disk itself. And we're introduced to why Spark is required and why Spark is much better than MapReduce or MR. We'll also understand the Spark ecosystem, various tools available in the entire Spark framework, such as Spark, the core Spark, you can say the interactive shell, plus we have Spark SQL. Anybody who would like to process data, structured data, so we can use Spark SQL for that. We have a lot of libraries in form of machine learning libraries and graphics libraries. Apart from that, we'll be also understanding what is Scala language, and certainly we'll be taking up examples using Spark and Scala toward the end of the program. And finally, we'll be having a question and answer session round, where I'll be answering all your questions related to Spark and Scala. So before we begin, you must have all understood what is big data, and I'm just repeating so that everybody's on the same page. Big data can be defined as any large data sets which is running into terabytes or petabytes, and certainly they cannot be processed since the data is very huge. It cannot be processed in any simple your traditional processing mechanism. And apart from that, if the data is huge, plus it's complex also. The word complex is important here. It stands for data coming from various sources. So if the data is sourced from a structured mechanism like an RDBMS or unstructured data set like your body of an email, or you can also have a semi-structured data coming from a JSON file or XML file. So when you have all three different types of data set being processed in a single framework, that data can be easily termed as big data, and which is not possible using any traditional mechanism or database management tools. But using Spark as a framework, I can certainly pull all the data into my system and process this data. The biggest challenge using big data is about how do we store the data, how do we capture it, and the first thing is how do we capture it, store it, process it, share it among different users, how do I transfer, analyze. These are all different challenges which can be overcome by using Spark framework or any other MapReduce framework. Now, who's generating this big data? This data has been coming from various sources, as I discussed with you. Like the first and foremost, the data is coming from your social media and network, which is huge amount of data. That is where people are targeting and using this data, because this data set is basically a gold of mine, a mine of gold, where we can extract a lot of valuable information about the likes and dislikes of the people, because by knowingly or unknowingly, we all are sharing our thoughts over social media platforms and sharing our likes and dislikes over a product or a category, or you can say or a service provider or any other category of topics. So we are sharing our thoughts over the subject. So that information will be stored and analyzed by the app developer. You can say whether it's you can talk about WhatsApp or you can talk about Facebook. So they are using this information to process it and get the valuable insight of human mindset. So this is, so in a way we can say that we are becoming the data generators today. Whenever we type anything across the platforms, using the platform to share it with your family members or friends, we are becoming data generators. Plus, we have also have mobile devices and
We have this one last thing you can share it. It's for the same.
just a moment, there is a lot of noise.
This is for laddus. No, fantasy. But in that laddu there is no, there were no kajus and all. That was normal one. This is special one. This is 20 rupees for one piece.
Hello,
Yeah.
there is some disturbance. Hello, can you please mute yourself? Thank you. So we have these mobile devices which have a lot of apps and they are also generating huge amount of data. Apart from that, we have new machines where every machine is equipped with sensor technology and they generate about a lot of streaming data 24/7. So we can use Spark streaming to process the data. So Spark allows me to process data in multiple fashions, like in a batch processing, also in a real-time processing. And plus we also have ATM and scientific instruments. Before we jump to Spark, let me also share with you that like there are multiple ways of processing data. One is a real-time processing and one is a batch processing. So this is a overall picture of any company which uses Spark or which uses Hadoop to process the data sets. Now this is the bottom layer is a source layer where we collect data from different sources. It could be a transaction data, a machine sensor data as I discussed with you, or a master data set, or a social media data. Now there are various tools available by which you can pull this data into your mechanism. We have Scoop, we have Flume, we have Kafka. These are all data ingestion layers where you will be pulling the data into your systems. Remember, you must have heard about or learned about in Hadoop, like your data has to be first pulled into your mechanism, your framework where you're going to process the data. You cannot just keep the data outside of the domain and process your data in a Hadoop or a Spark framework. Then we have two types of framework, basically a speedy layer or a batch layer. Now, speedy layer is a layer where you can use Spark streaming. In a batch layer, either you can use Spark as a batch processing mechanism, or you can use Hive or Pig. There are various tools available. So this is where the Spark and Storm comes into picture, and you can use Spark for Spark streaming and also for a batch layer processing. And after that, you can mix and match both your batch results or real-time results. अरे अपना नेट बंद करो. You can mix and match both the real-time results and a batch results, and finally get some real-time query analysis or a batch analysis reports. So this was in the context of using Spark, where exactly you can use Spark in your Hadoop or These are different sources we just talked about, and they are all pulled into the framework before we analyze them. A small comparison between structured data and unstructured data, and this is the data where everybody is targeting today. The blue part is you can say is a denoting which is unstructured data, and the red one is basically the structured data. The growth of structured data is very gradual, and we can say the growth of unstructured data is very exponential. And this is the data where people are targeting, and they would like to use this data as early as possible, because the life cycle of this data is very short. And why it is short? Because today what people are thinking and typing and basically messaging across the digital platform may not be thinking the same way 2 months down the line. So whatever data we collect today, it has to be analyzed as early as possible and get a meaningful output out of the data. Because one needs to understand the mindset as of today. That mindset maybe can be changed after a couple of months. Now there are different solutions available. As we discussed, I showed you in the earlier chart about using different technologies. So we also have Hadoop for storage mechanism. So Hadoop is also storage mechanism for batch processing. We can use Cassandra for real-time storage mechanism, and we can use Spark Storm for doing some real-time processing. We can use Hive and Pig for batch processing, and plus we also have another storage mechanism called MongoDB, which is also getting very popular. So MongoDB, Cassandra, these are NoSQL type of databases. Spark, Storm are processing framework. Spark is more like a processing framework, and Storm is a real-time processing tool where I can process my data real time. But Spark also has one inbuilt tool which is called Spark Streaming, which does the same thing what Storm does. Now we all understand the data is stored in SDFS, or it can be stored in Cassandra or MongoDB or Edgebase. There are various storage mechanism available. Now the key part is that whatever data is stored in a distributed fashion. Remember, you must have read and learned about how the data resides in SDFS and what SDFS is all about. It's about Hadoop or distributed file system. So every file is stored in a different blocks, and those blocks are located across different machines in a big cluster. And we need a mechanism where we will be processing all these blocks separately and parallelly. This is what is done in MapReduce. Now Spark, there is another, the technology used in Spark is totally different. What happens in Spark that we read the file into a memory. All the data is first loaded into a Spark memory. Now where is this memory residing? Spark uses all the memory of all the machines put together. For example, if you're having 64 MB of memory on each machine, there are about 1,000 machines in your cluster. So in all, you'll be having 64 MB into 1,000. That much amount of memory would be available for you to utilize in your cluster. So it creates an RDD, basically creates resilient data sets or distributed data sets across the cluster, and it partitions the data in RDDs, and every RDD is basically residing in the memory of each machine. So it divides the data into n number of RDDs, and those RDDs are processed in the memory on each machine. That is how it is said that Spark is much quicker and faster when you compare with MapReduce. So it was introduced by Apache Software Foundation for speeding up the Hadoop computing software process. It is only after MR this technology was introduced so that data could be processed much quicker and faster compared to MR. Apache Spark is a lightning faster cluster computing technology designed for fast computation. The main feature of Spark is its in-memory cluster computing. Just now I told you that all your data gets divided into RDDs. RDDs are basically your resilient distributed data sets, and they are stored in the memory of each machine. And then you can cover a lot of different workloads such as batch applications. You can write algorithms, interactive queries, or streaming data processing mechanisms. This is just an overview of Spark to understand how Spark works. And it provides basically three types of languages. It supports three types of languages: Java, Scala, and Python. Java, we all know it's an object-oriented language. Scala is a fourth generation language, and the amount of coding required in Scala compared to Java is very less. You can say about 30 to 40 lines of Java code can be easily written in Scala using just 3 or 4 lines of code. And it also gives you an optimization process mechanism, and it also supports general execution of graphs. Apart from that, Apache Spark provides various high-level tools like Spark SQL for structured data. So you can also you can pull your Hive data sets into your Spark SQL memories, RDDs, and process the data in your Spark. And nowadays it's also supporting Spark R programming language for analyzing and for predictive data modeling, and machine learning libraries for machine learning, etc. So it provides a lot of various features in one club into one framework. And certainly it supports different languages like Java, Scala, R, and Python. Now, why would one need a Spark when we already have a MapReduce programming technology? We all understand that we have mappers and reducers. Mappers are basically we filter the data coming from each block, and then a reducer will basically run an aggregate function on the each data results coming from the each mapper output. But during that process, the intermediate data is always written on the disk. Suppose we have a 10 node cluster or a 100 node cluster. Now, if my data is divided across in blocks across cluster, every block or every node block would be processed separately, right, by running a mapper class. Now, after processing the data or that block or 128 MB by that mapper class, the results would be then written on the disk itself. And finally, all the data would get accumulated on another disk coming from all 100 machines. So first it will be writing on the disk, and then it will be copying the data from one machine to the common locality where the data would be used to run a reducer on that data set. So we can see that there is a lot of reading and writing happening with the disk. We read the data, we write the data on the disk, and that leads to a lot of, you can say, processing time being utilized more when you compare in-memory processing framework. So Spark, in a way, when you compare MapReduce with Spark, now what this Spark will do, instead of processing the data by a mapper class, it will create an RDDs. It will divide the data into equal number of RDDs, and your data would be partitioned in the RDDs, and RDDs will be stored separately on every machine memory. And then you would be running the processing code on every block separately, and using the entire memory to process the data as a single file, as if the entire data is loaded into a single file or a single memory cluster. So it uses the entire memory of the entire cluster and processes the data in a way that your data is processed much faster and quicker. Now, when you compare MR with Spark, what is the major difference? Whatever the loading time takes place into the memory, that remains the same, whether you're using MR or Spark. Remember, we also have to load the data. When I'm using the data in MR, I'm also loading the data. So I'm loading into my memory, and then I'm processing the data by a mapper. Then I'm writing the data on the disk, and then I'm again writing the data on a common locality to run a reducer on that data. And finally, I'm processing the data in the memory again by the reducer, and then I'm writing the final output on the disk again. But in this case of Spark, the reading, the data has to be first read into the memory. So that much amount of time taken by Spark or MapReduce is same. But after that, the amount taken by Spark to process the data is very, very less, because entire chain of process, whether it's map or reduce, anything which we write code, everything is done in the memory. Apart from this one important differentiation between MR and Spark, we can also identify that I can create multiple RDDs from an existing RDDs. That is a very important part. Unlike in MR, I cannot create a mapper from a mapper, or I cannot write different mappers, a chain of mappers. I have to break my program. But here, once I load my data into my memory, I can write different RDDs. I can transform those RDDs into new RDDs. And this process of transformation of RDDs is called transformations in Spark. So Spark basically has two main mechanisms. It has transformations, and it have actions. So we can transform the one type of data. For example, if I need to filter a data on some criteria, so I'll create a new RDD with a filtered data. Maybe the third RDD will create a more segregated data on some other analysis. In that way, I can easily recreate new RDDs, and finally, on the last RDD, I'll be calling some action, some aggregate function value action, where I'll be running some business logic and calculating the final result into some sort of logical result. And that action is ultimately, you can say, the final action run on Spark, the way we ran reducer on the MR programs. The final output can be saved on the disk, just like we save the data on our in MR. The same thing, the data can be saved on the final disk also, on the disk itself, after we get the results finally. Inbuilt, whatever data we had processed, number of processes take place in Spark. None of the processes data is stored on the disk. Everything which is stored in the memory only. And that is the reason we can say that it runs 100 times faster in the memory and 10 times faster when running on the disk. No, Tapas, the old RDD remains till you complete your project, till you complete your program. You cannot remove the old RDD, it remains in the memory. Because I can still use that RDD again. Why? Because the moment you load a table or a data set into your memory, that that itself is an RDD. So I can use that same RDD for some other purpose also. I don't remove the old RDDs. All the RDDs remain in the memory. And supports multiple languages. You can say, again, it's repetitive. I'm repeating it: Java, Scala, and Python. And you can write in different languages. And they come with a lot of operators, and you can say a lot of inbuilt functions for interactive query. It has a lot of, as long as you are there in the Spark memory, the RDD remains. Or you can overwrite those RDDs simply. You can use the same name of an RDD and you can overwrite it. Nobody stops you from overwriting it. If you want to delete those old RDDs, you can simply overwrite it. Old RDDs can be only be deleted by reusing those RDD names for some other RDDs. So Spark not only supports MapReduce, apart from MapReduce, it also supports SQL queries, streaming data, machine learning libraries, and graphics algorithms. These are different features, functional features of Spark. It provides powerful caching and disk processing capabilities, a faster batch processing, and Spark streaming certainly used for real-time stream processing. and you can use machine learning libraries for faster decision making, and also use iterative and interactive data analysis algorithms to write all those programs. These are the main components for Spark, and Spark can also work on with the help of Yarn. So I can use SDFS as my storage mechanism. I can also use Mesos, which is also a sort of a resource manager, and plus I can also work Spark as a standalone. So I don't need Hadoop to work on Spark. It can work as a standalone scheduler. And the main components of Spark, again, I have a Spark core where I can do some interacting processing. Apart from that, I can also use Spark for stream real-time processing, just like Storm, and use machine learning libraries, graphics libraries where I can process my data or graphic data. Apart from that, I can also use SQL data or structured data to process using Spark SQL. So it provides a whole bunch of libraries and functions, and nowadays getting very popular because due to all these features, and a lot of companies and people are investing time, money to learn and have some expertise because it's very new technology, and to get understanding and to get the maximum benefit out of it, people are trying to master this technology as early as possible. And what does Spark Streaming do? It enables analytical and interactive applications for live streaming data. So you may be having a lot of streaming data coming from different sources like stock market or any commodity market, and you want to do some fraud analysis. You can easily use Spark Streaming, and Spark SQL. We all understand we can use Hive data sets to process data, or we can bring Oracle data into Hive using Scoop, and then we can use Spark SQL structured data mechanism. And certainly machine learning libraries are very useful for understanding the technology. For example, if we have different like we have a lot of cameras in the city, about 2,000 cameras, and we want to capture some unusual event. So we can set up some sort of mechanism, and then we can just identify those frames or those cameras where it identifies and matches those machine learning algorithms. So certain algorithms can be set up with that, and we can easily have a special monitoring done for that particular camera. And it also Spark also allows you to use Yarn architecture and use your data stored in SDFS. And what is Spark SQL? So Spark SQL is a component on top of Spark Core that introduces a new data abstraction called schema RDD. So just like we have RDD in Spark Core, we have a schema RDD. When you load your table, your schema RDD will be having the entire rows and columns being stored in schema RDD. And this schema RDD will be residing in the memory. Just like your RDD data sets resides in the memory, for Spark SQL you have a schema RDD which resides in the memory, and then you can use various functions and algorithms to process the data in the memory. But the basic idea for Spark is that it is in-memory processing. When you just compare with MapReduce, and Scala is a language, or you can say Spark SQL is there are different tools available by which you can process your data in Spark. So learning those tools will be little, you have to spend some time, and certainly companies like Kratoes will give you a better platform to learn Spark in a more understanding way, and you have to dive deep and learn more about different languages, or like Scala. And secondly, Spark Streaming leverages Spark for fast scheduling capability to perform streaming analytics. So I just gave an example where data would be coming from various sources into your system, and you would like to do some real-time analytics. The one which I showed you earlier in my program about this one, the real-time data processing. So I can use Spark Streaming in my speedy layer. Once we have batch layer, another layer is speedy layer. So I can use Sparks as a Spark Streaming to process my data as the data gets produced and being ingested in my mechanism. So it ingests data in mini batches. It ingests data, or it loads the data in mini batches and perform RDD transformations. So basically it performs transformations, and finally we are writing actions on those transformations on those mini batches of data. We have a machine learning library algorithms where can use the in-memory distributed memory based Spark architecture, and when you compare with Apache Mahout, it's much faster using this Spark machine learning libraries. Also, it can be used for using graphics or for graph distributed processing framework. And these are different companies which are using Spark in the industry today. And to name a few: Yahoo, Mapr, Hortonworks, and Cloudera. These are all distributed packaging company which are providing Hadoop as a package, plus they are also providing different Hadoop ecosystem packages. Apart from that, we also have Amazon, Intel, IBM, which are using these products to the best advantage. Now, to run a Spark program, we need a language, and we know that there are three languages you can write. You can write in Java, Scala, and Python. But Scala is a fourth generation language, and you can say it's been a very less number of lines, or with the help of very rich libraries it has, inbuilt functions it has. You can use the Scala functions, list of functions, and reduce the lines of code in Scala by 90%. So if you are writing code in Java, it takes 30-40 lines. The same thing can be written in Scala in just 3 or 4 lines. And Scala has a full support for functional programming and a very strong static type system. And certainly all that language is converted into bytecode, and they run on JVM. So they compiled and they converted into Java bytecode because that is how the framework understands, and then run on the code on the JVM, separate JVM. Scala is object oriented and uses a curly brace syntax of C programming language. And this is a bit history of Scala, publicly released in 2004 January, and later on it was released on .NET platform. So it gives you a functional programming plus the option of object-oriented programming, and the best of both the worlds. So you can use and reduce your amount of effort in writing the code. So the time will be more spent on the logical part rather than the coding and the debugging part, which does not happen in the case of Java, because in Java you end up giving a lot of time to the coding part and the debugging part. And these are the companies which are using Scala nowadays very oftenly, whether it's Google, LinkedIn, SAP, or Sony. These are different tools available in Scala, like Play, Scalding, and Kafka. And Kafka is getting very popular because it has become a messaging queue where you can store your data also for buffering, for streaming data in your, and you can also process your data using Kafka. And these are the usages of Scala. You can use Android application, messaging, web application, you can use for scripting and graphic user interface. So it can be used for different applications, and very well gelled with Spark. So let us now show you some demos on Spark before I start taking up questions in the last 10 minutes. So this is my VM which I have created, and remember you need to install your Scala and Spark first before you start using Scala and Spark. And I'll be using SDFS also, or as a local file system also, to store my data. So let us start my terminal. So I'll be starting first my Hadoop services so that it allows me to use my SDFS. And the command is start-all.sh to start my SDFS. It starts two daemons basically, the two main components, the SDFS part and the yarn part. SDFS again has three main components: name node, data node, and secondary name node, that you must have learned about in MapR and MapReduce and SDFS part. In yarn technology, we have two main processes. We have the resource manager and node manager. So if you want to learn about SDFS and yarn, we have separate webinars for that also. Now I can use Spark shell to enter into my Spark mechanism. So currently I'm using 1.3.1, and so there are two types of framework available with the Spark right now. I can use SC as a Spark context, which is available, and for SQL context, I can use SQL context. So I can use SC as a variable, or you can say a tool to access my Spark. So I'll be using this tool to first connect to Spark and load my data into my as an RDD. So I have one file with me. I'll just share the file with you first so that everybody is on the same page. The file name is sample.txt. So I say nano sample.txt. So this is a small file and it has a lot of lower cases and upper cases. So my first case study is about if I want to convert all the characters or the letters available in this file in lowercase. So that is my first objective. So let us see how I'm going to handle this. So initially I have to first load this file into my memory as an RDD. So here it is. I'm loading the file using SC as an object because that was provided by my Spark. So I say val. Val is an immutable, you can say data type or RDD. So all these RDDs are basically immutable type. I cannot modify them. At the most, I can override them. So here I'm saying val input file is equal to sc spark context dot text file. So I'm loading the file and I give the path into the to the file name, and I'm loading that file in the memory. Okay, now if you want to see the contents of this memory file, which is input file, I can say for each dot, okay, just a moment, input file dot for each bracket println. This will give me the contents of the file. So there it is. You can see the contents of the file which is loaded into the RDD. Now I can use one of the functions available to calculate or to convert into lowercase. So by using this command, it will convert everything into lowercase. So I'm basically writing a mapper class here, input file dot map. Every record is basically I'm defining as a line, and line to lowercase. So every in every RDD, when we partition the data in RDD, every record every line becomes an individual record. So I'm giving a record identifier line and line to lowercase. And please understand that is done by the framework. We don't have any control how the RDDs are created in the memory in on each machine. And now we can say we can print this command. I'll get everything into lowercase. See, all the data has now converted into lowercase. So if I were to write the same code in Java, I would have used at least 20 lines to 10 to 20 lines to just write the classes and import the classes and then convert into lowercase. Here I'm just using one function to lowercase and it converts into lowercase internally. Similarly, if I were to convert into uppercase, then now I no need to load the file again because that RDD is already being created. Input file RDD is already been created. From the same RDD, I created one RDD called lower. I can also create a new RDD called upper now. So the same RDD, I can create multiple RDDs. This is a major difference which is not possible in MR, in MapReduce. Here you will see that I'm creating one more RDD by the name of upper and will convert all the text into uppercase. The same RDD, as earlier somebody was asking me that should I remove? No, you should not remove any of the RDD because you can reuse that RDD in your project. So using the same RDD, I'm bringing the data into upper RDD. And now I can also print the data. And we can see all the characters are being now converted into uppercase. All the characters are now. So the logic is that I can use the same RDD to create new RDDs, and then I use different functions to process those RDDs. Because I don't have to reload the data. The data is already there in one of the RDDs, the original data. Now, if I want to calculate the length of a file, how many characters the total file has. So again, I will not load the data. I'll simply use the same RDD. So I'll use input file. So I'll say val line length and now I can simply say I can reduce them, I can calculate them the total length because the line length will give me the each length of each line. If I say line length command, it will give me length of each line. So there are total 6 lines. So there are 6 lengths available for the line length. But if I want to calculate for each RDD, remember I am getting from each RDD chain, I have to calculate separately and bring them using a reducer. So I'm using a reducer here to calculate the total length. And these are all commands and functions available. You have to learn about reduce function, the map function, and different functions available. Don't just get about scared that how do we use those Scala functions. It will take a little time to understand, but once you understand them, then you can use them very effectively. So here I am reducing it a comma b and giving it to a plus b. Basically, what is happening? If you understand this function, reduce function here, normally when we write, when we add some values in an iterative form, we say value is equal to previous value plus current value. So here A signifies your previous value and B signifies your current value. So just adding up the previous value plus current value and keep on adding up. Suppose in this case we have 6 characters, so we pick up 23 as A, B as 14, then A becomes 41 and B becomes 18. Then 41 plus 18, then A becomes 59, then B becomes 36. So you keep on adding up and then finally you come to the final result. So it will take some time to understand the logic and the coding part or the function part. But since Scala uses functional programming, it becomes very, very less amount of coding compared to Java. So the total length is 133 characters. I can also print this value where I'm storing in total length val, and I can say print L total length of all characters equal to, just print me the value of the total length. So the answer is total length of for all the characters is 133 numbers. So this is just few examples. Now I'll take one of the word processing using Spark. How do we load the data? So first, the data is already there, and I'll be creating one more RDD which is called transform, and transform will basically, now what happens in this flat map, we need to understand. It divides the data and then splits. First it's splitting the data on space, so every word in a line gets split into separate tokens, separate words, and those words are basically again separated by different tuples. So the file is already there in the memory. I'm not loading it again. I'll just show to you the file again. So there are about 6 lines from welcome to class to uppercase words. And I'll use the map function, flat map. So basically, the flat map is basically a combination of flatten command and mapping. So I'm first mapping it and then flattening it. So if anybody has done Pig, we had used the same functionality in Pig also. So transform is equal to input file dot flat map, and I'm splitting the line because line is a record. So record dot split into every space, and then I'm flattening out every record. So every word welcome to Hadoop class will become 4 tuples or 4 records. Welcome will become 1, 2 will become 1, Hadoop will become another one, and class will become another one. Now if I want to see the result here, so I can use transform for each println to see the output, how the output looks like after using a flat map function. So you can see after using a flat map function, first I have broken the words into into separate tokens, and these tokens are now listed in separate lines, as separate records or separate tuples. And now I'll be giving a value 1 to each of these tuples, each records, because each keywords, because I'm going to use them as a mapper class, and I'll give them into every word. So I create a third RDD. First RDD was input file, second RDD is transform, and now I'm creating a third RDD which is key by word. And if I do the same thing again to just print it, so now I got a key value pair, welcome comma 1, 2 comma 1, so on till last is words comma 1. Now all I have to do, I have to just run a reducer on this, and it will calculate the number of occurrences for each word together and give me the final result. If anybody has done MapReduce programming in Java, at least you require 80 lines to write this code. At least 80 lines. And here we are just using 3-4 lines to finish the entire coding part. So there are two ways of writing. Either I can say a comma b, which is equal to a plus b, or I can use underscore plus underscore. So that part you will learn when you dive deep into Scala language. As you learn about, you can understand all the different ways of writing functions. But the function which I am using here is a key by word dot reduce by key. So reduce by key is the main function here, and key by word is a RDD. So I'm using an old RDD to create a new RDD, and the new RDD name is counts here. And I'm also sorting it, so the result will be also sorted in my final output. Now I can run the display part here. And there it is. So the first uppercase words will come because it has a lower NSI value and SKI value, and so we have this case comma 1 upper, words comma 1, A is coming 2 times, R is coming 2, Hadoop is coming 2 times, and this is coming 2, else everything is once. So this is a word count processing mechanism program in Spark, using Spark, where within just using 3-4 lines I am able to process my entire data set. And up till now, remember, the data is in the memory. If I come out of Scala, I lose my output. If I would like to save the output in my, I can just save it there. I can use Scala result. So it will create a folder Kratoes, and under Kratoes another folder Scala result will be created, and to store the results in that folder. So there is another function called save as text file. Now I can go back to my and say cd Kratoes and cd Scala result, and see the file name part R. So we have two files always, as success file is a 0-byte file, just denotes that your distributed processing has done successfully. And then we have the main file, which is part. So if I say cat part 00, this is my result, and now I can use that result in some other program to process my data further. So this is how normally you process your data in using Scala in Spark. So guys, if you have any questions, feel free to ask. We have 7 minutes to go. I use Spark shell to enter the Spark program or Spark module. You can say RK. RK is asking, we cannot see the Spark shell prompt. Normally we see the Scala prompt when we are using. A data frame is basically, you can say, a schema RDD, and RDD is a data frame is specifically more specific for structured query purpose. RK, for the slides, you can get in touch with the support staff. They can help you out. As a trainer, I don't have any authority. And we are offering eight session course for this entire Spark and Scala tutorials. The first session will be about introduction to Spark and Scala, and then we will understand the Scala language more deep and understand the different aspects of Scala, functional programming in Scala, using how to use different functions. Because the moment you understand how to use functions in Scala, different functions and usage of functions, then your coding becomes very simple. You can correlate and you can use the proper function immediately, because that you don't have to spend a lot of time in coding, because you have to you have to know which function to be selected for what purpose. That is more important. So selection of a proper function in writing the code is more important. And certainly we will be diving into understanding Spark and Big Data, understanding RDDs, and we'll also cover Spark SQL in your module. The last session will be about advanced Spark concepts like machine learning libraries and graphics. And finally, we'll be ending the curriculum on project using a project discussion. RK, the cost of the course will be given to you by the support staff for Kratoes. Please get in touch with them. And why Kratoes? Because we have 100% placement assistance. We give you 24-hour support even after the class ends. So in case you have some difficulties after the course has gone over, so you get lifetime and access to your course content. And plus we have good instructors where it will be totally instructor-led classes. And those certificates are easily recognized by all these corporate partners across different domains. So we are associated with Wipro, Infosys, all these companies where will be easily recognized by them after you complete your course. And get in touch with us. These are the numbers. If you are connecting from US, then number is 646-362-6476. And if you are connecting from India, then the number is 7022-551245. Alternately, we can reach us at sales@Kratoes or regis@Kratoes. So the total duration is 24 hours. Tapas, for that, yeah, got the answer from Arushi. Every session basically for 3 hours, so we have 24 hours. We have 8 sessions, so the entire duration is covered in 24 hours. So guys, that's it for today. If you have any more questions, you may ask the support staff. In case any technical questions you want to ask, you feel free to ask me. Thank you, RK. Thank you, Tapas, for joining the session. I appreciate for all of you guys for spending some time and taking part in this webinar. Thank you. Bye bye. Take care.